Okay, so to finish up our notes for section 1.4, we have two more definitions to look at. First, complementary angles. Two angles whose degree measurements add up to 90 degrees. Okay, so let's look at the first example. I know when I put that symbol in there, that means those two rays are perpendicular. And I know the measure of that angle is 90 degrees. So if I draw an angle from the same vertex, now these are two adjacent angles, and we can do, let's say this is 45 degrees, and then this would be 45 degrees as well. So what does that mean? I know that these two angles, I'll name these A, B, C, and CBD are complementary. Why? Because the measure of angle ABC plus the measure of angle CBD, they add up to 90 degrees. So recall, when two angles share a common ray, these angles are adjacent. Okay, they have that ray in common. Complementary angles do not need to be adjacent though. So I can have this angle ABC, and we'll give that 30 degrees. And then I could have an angle JKL, and if I make the measure of that angle 60 degrees, then these two angles are also complementary for the same reason. The measure of angle ABC plus the measure of angle JKL, they add up to 90 degrees. Okay, so make sure you have that in your notes. These are adjacent angles, they share a common side, but these being non-adjacent, they can still be complementary. Okay, so let's look at a couple examples. Part A, set up an equation to find x and then solve for x. We're going to set up each equation together, and part B is going to be for homework. Solve each of these equations for x. Okay, so for the first one, I see my perpendicular mark, which means that these two angles must add together to 90 degrees. So that's my exact equation. 5x plus 25 has to equal 90 degrees. All three of these examples are adjacent angles. Okay, they all have a common side. So for the second example, 53 degrees plus the expression for this angle measure, 5 plus 4x, that has to sum up to 90 degrees. Sorry for that. And then lastly, so now both of my angle measures here are expressions in terms of x, but I still have my 90 degree marking. 3x plus 6 plus 5x plus 4. And because of that perpendicular marking, I know that the sum of those angles has to be 90 degrees. Okay, I have two more quick slides, but finish those three for homework. Find the value of x for each of those equations we set up. Okay, then lastly, supplementary angles, two angles whose degree measures add up to 180 degrees. So recall from our notes for classifying angles, the measure of a straight angle is 180 degrees. So when we look at supplementary angles that are adjacent, two of the rays will be opposite. So let's put that as the vertex. And now I put the one ray in the middle, and now I have an example of adjacent. So AVP, and then PVM, and I can say that regardless of what these angle measures are, measure of angle AVP plus the measure of angle PVM are going to add up to 180 degrees. Why? Because when I trace the angles, A to V to P, P to V to M, what have I traced? I've traced a straight angle. And what's the measure of a straight angle? 180 degrees. So these are examples of our adjacent supplementary angles. But just like complementary angles, these do not need to be adjacent. Sorry, keeps moving. So if I make this angle 120 degrees, okay, that's my one obtuse angle. And if I made this angle 60 degrees, then these two non-adjacent angles are still supplementary, because when I add their angle measures together, they sum to 180 degrees. All right, we're going to set up two quick examples, and same as complementary, we'll set them up, and for homework, you solve them for x. Okay, so for the first one, I notice angle ABC is a straight angle. So my equation, x plus 65 is going to equal 180 degrees. For the second one, these angles aren't marked with letters, but I know they're adjacent, and together they form a straight angle. So 2x plus 30 plus 2x minus 10, those two angles are going to sum to 180 degrees. Okay, please complete those for homework and we'll check them in class.